Hi, my name is Fred Crick. I'm one of the Bosch factory guys that are running around doing training. What you're looking at here is one of our training carts that we have to bring to the distributors and bring to the contractors. But what we're going to do today is we're going to go through the IOM and somewhat the quick start guide and to show you exactly how to install and set up one of these Bosch IDS units. We have on our cart is a 20 SEER, basically the highest SEER rating that we have in the family of Bosch. And what we're going to do is we're going to go through the setup just like you would out in your territory. So let's start with the refrigerant line sizing and links. The book says that you can separate the 20 SEER by 150 foot of line set. And what we're looking at here is the diameter of line set on this 3-ton unit, basically 7/8, 3/4, and 5/8. So that's the suction line, and then we have the liquid line. The liquid line is always 3/8. We're always going to make sure that we install the filter dryer that comes with our unit. But in the book, it tells us that we have the capability of running our system in an air conditioning mode only and a heat pump mode only. If we're in a heat pump scenario and you've got snow out there and it's going to be in that wintertime situation, we're always going to elevate this above the snow pattern. So if your snow pattern is 8 inches, we are going to need to get this above that 8 inches and so on. So in the wintertime, this is now the evaporator. It's going to make some water. It's going to have the capability of freezing, and we don't want that water to get into the ground and basically freeze all the way up to the coil. So when we're looking at the situation of the refrigerant lines, we're looking at how do we do the refrigerant lines. And guys, if you've been in our industry for a long period of time, you know that as we are brazing these lines, we're going to flush the inside of that refrigerant line with nitrogen, probably 3 to 4 pounds of nitrogen, so that we get all of that junk, that black, that carbon out of that refrigerant line. Then, of course, we're going to dehydrate those refrigerant lines to 350 microns. That's what the book says. And then we're going to look at how do we measure our refrigerant, and it's in the book. And guys, when we're talking about the way that we're going to measure our line set, our 5-step chart basically is allowing you to measure the refrigerant line. Take a tape measure and measure it. Well, I can't go up that wall and all that kind of thing. Then you go get you a Bosch laser tape measure and you measure that refrigerant line. And when you do that, you just put it on number 1. Number 2 tells us that this machine comes with 15 foot of line set ready to charge. That's refrigerant inside the machine equivalent to 15 foot of line set. So you're going to measure that. You're going to go to number 3. You're going to take the differential of your measurement versus the 15 and get a number. That number now is going to be it's going to be multiplied by 0.6 ounces of refrigerant. So what we're going to do is after you dehydrate those refrigerant lines, we're going to put that refrigerant, that adder that you have, we're going to put that back into that. We don't use fish scales. We don't do an assumption type scenario, critically charged piece of equipment. And you say, well, Fred, how come you're so, how come critically charged? You see, when you're looking at thermostats and you're looking at the way that my system can be wired up on the thermostat scenario, you're looking at different types of thermostats. We really are so simple, even though we are a stepped, a variated compressor, we're so simple that literally you could run my system. The thermostat could literally be a wire nut. That's how simple we are. So you pick your thermostat. If you need to pick your thermostat and make it work, then that's awesome. We do have a BCC 50 little brother and a BCC 100 thermostat that Bosch makes. It's an awesome thermostat. We would really enjoy you using that also, but here's the thing. I do not communicate through the wiring on the thermostat. I communicate through the refrigeration lines. That's why we have to be critically charged. We say, well, Fred, can I be 10 ounces above and 10 ounces below? No. 6 ounces basically is the key. 6 ounces too much, 6 ounces too little is what we're looking for. So we've got to be very, very precise on the refrigerant charging. When we're looking at wires, we're looking at 4 wires coming out to the condensing unit. Making me a heat pump. Give me a Y, that's basically turning my compressor on. Giving me a common. If you just use those 2, I'm an air conditioner. But if you want to make me a heat pump, give me a B operated reversing valve. That means that I am energized in the heat mode, not the O, not like a lot of other heat pumps, but I'm energized in the O, and then I will also have a W wire. That W wire is very simple. It is energized when my system is in the heat pump mode and goes into a reversing or a defrost type scenario. We're going to send voltage back to whatever you have it tied to. If it's electric heat strips, you're going to illuminate those electric heat strips. If it's a gas-fired furnace, you're going to illuminate that that gas valve. So here's the thing. Very, very critically charged. You got to remember that. Simple thermostat. Got to remember that. And then we need 240 volts single-phase power coming into this machine. You say, well, Fred, what's the power on the machine? What's the amp draw? They're always located on the nomenclature plate. Whether it's a 3-ton unit or a 5-ton unit, you're going to look at that and you're going to get the amp draw, the breaker size if you don't mind, or the disconnect on that. So when we're looking at installation practices, thermostat is always the key. My deal is keep it simple. If you have a simple thermostat, you're going to make my unit run really well. If you got a refrigerant charge and it's correct, my unit's going to run really well. We get outside those boundaries, whether it's an elaborate type thermostat that wants to think about it, and basically those learning thermostats may not be the key to my unit. So keep it simple on the thermostat, be critically charged on the refrigerant side, and my system will work. We say, well, Fred, what does it work with? Today I have it hooked up to electric air handler. This is the 3-ton unit on a 3-ton air handler. I could have this same condensing unit on a 2-ton air handler. And you're saying, whoa, hang on a second, Fred, what do you mean about that? This particular unit, BOVA 36, can actually be a 2-ton air conditioner or a 2-ton heat pump also. That means I have a switch located on this particular board, and I'm always going to call it a smart board. But I have a switch on this board that allows me to deregulate the top end or take the top end off of this unit. Remember that my compressor is a stepped type compressor. It's a variated compressor. It's not your old grandpa's unit where it's only one speed and it only has one speed to give you. My system, again, load matches what's going on inside your structure, and it will variate the refrigerant capacity, if you don't mind, based off of what we need inside the system, inside your structure. So, load matching, remember that. So in the process of load matching, I have the capability of deregulating this particular machine, and when I do, I'm basically taking the top end off of this machine. So people ask me all the time, say, well, how do you deregulate? How do you take the top end off of that condensing unit? And it's very, very simple. Unplug the unit, disconnect, pull the power down, take the J2 switch that is up here on this board, and basically move the switch. When you move the switch, all you're doing is you're taking the top end and making this system a 2-ton system instead of a 3-ton system. With that, you are taking your foot off the gas pedal, if you don't mind. So literally what we're looking at here is we're capable of matching our AHRI numbers, 2-ton with a 2-ton air handler, 2-ton with a 2-ton coil, 3 and 3, 4 and 4, 5 and 5, that type of scenario. And we do that with a switch. Now, that particular scenario, we probably would never tell you to move that switch, in that my system can automatically deregulate its 3-ton capacity and match it up with a 2-ton coil. My 5-ton unit can automatically change its capacity to match up with that 4-ton coil, automatic. So there's very, very few times that we literally would tell somebody, flip the switch, make that unit a 4-ton, make that unit a 2-ton by just flipping J2. That's the deregulation or the loss of capacity switch that we would have, J2.